This lesson is about mathematical modeling. So let's start with an example. We've got a set of data of population versus the year for Wake County over the last 110 or so years. We're asked to find a prediction model to determine our model's goodness of fit, and then to use the model that we found to predict population in two different years, 1978, and then actually to find what the population will be in 2020. So let's start off by putting this data into our calculator. So on our 83s or our 84s, if you press the stat button and then the edit, press enter for edit, then we can put our years, which will be our independent variables, in L1 and our population in L2. Okay, I've already done that for time's sake. Okay, next thing we want to do is get a visual of this data. So if we go to stat plot, so second y equals, and let's turn plot 1 on. Let's make sure we have scatter plot selected, and we want to pull our x's from L1 and our y's from L2. It should already be set up that way. Okay, then if we press zoom, let's quit out of there, press zoom 9, ask our calculator to fit a window to our data. Okay, so here are our data points. Okay, now just looking at the data, it definitely looks exponential, and whenever we're dealing with population, the first thing that should pop into your mind is an exponential model. But for the sake of this lesson, I'm going to forget that this looks like a population or like an exponential model at first, and I'm going to go fall back on the old reliable linear regression model. So the first prediction model that I'm going to try is a linear regression model. So I'm going to go into stat, cursor to the right to the calc menu, and option 4 is a linear regression model. So I'm going to click on that. I need to tell it to pull x values from L1, y values from L2, and I want it to put that linear regression equation into y1 so I can graph it. So I'm going to call on y1 as my third argument. Okay, and then I press enter, and I get a whole lot of information. We've got what our equation, the form of our equation, so it's y equals ax plus b, and then they tell us what our a value is, which is our slope, and our b value, which is our y-intercept. Okay, and then depending on if your calculator is set to it or not, you might get these r and r squared values. If you didn't get these, if you press second catalog, which is 0, and then press the D key and cursor down to diagnostics on, press enter, enter again, and then if you recall your linear regression, so second enter twice, and do it, and press enter, you should get those r and r squared values. Okay, so they tell us kind of a first idea of how good our model fits to our data. So our R value here is 0.8732, yada, yada, yada. We want that number to be closer to 1 or negative 1, but positive 1 in this case. 0.87 is close to 1, but we want a number bigger than 0.9, maybe even bigger than 0.95 to have a good model. So that's the first indication that maybe this linear model isn't the best fit for this data. Next thing I want to do is look at the model on top of our actual data point. So if I go into y equals, then I see our calculator's put that model into y1. My plot 1 is still selected, so I'm going to press graph. And there's our linear model on top of our actual data. Okay, so it does have a positive slope. It is increasing like our data is increasing. But I see some issues here. It looks like for values to the left of maybe this third data point, all my predictions are below my actual data. And then between that point and let's say that's probably 1990 or 2000 or so, then all my predictions are above, And then for anything after that, it looks like it's going to fall short of actual values. So I'm not liking this, but again, I want to put it through all the tests. So I want to find the residual plot for this model on top of this data. So I'm going to quit out back to my main menu, and I actually want to jot down that equation. So I'm going to pull that back up, and if I write that down as my first prediction model, I would write it down as y equals 6,400, and we're going to round to 3 decimal places, times x plus a negative 1, 2, 2. Okay, so there's our linear model. So back to residuals. So in order to determine the model's goodness of fit, I've looked at my R value, I've looked at the model on top of my data. It's not looking good. The last test I want to do is look at the residuals. So if we go back into stat plot, I'm going to turn plot 1 off. And I'm going to go into plot 2. I'm going to turn plot 2 on, and I'm going to change my Y list. If I go into second list, and number 7 says resid for residuals. I'm going to select that as my Y values. I'm going to go back into Y equals. I'm going to turn off my linear model and then refit my window. So zoom 9 to that data. And here's our residual plot. So along my X, I've still got my actual years, but along my Y, instead of the actual population, I've got the predicted population of those years using this linear model. Okay, notice the pattern. It looks not kind of parabolic, but definitely has a distinct pattern. That's not good for a model's goodness of fit. Okay, when we see a pattern like this, that's a clear sign that maybe there's a better model to fit our data. Okay, we want to see randomness. We want to see points above and below all across our x-axis. So I'm going to say that our linear model is not going to be the way to go. I'm going to go back into my Y equals. I'm going to turn off that residual plot, go back to my regular data plot, turn that back on, refit our window for zoom 9. And now I'm kind of coming to my senses. I think maybe an exponential would be a good fit for that. So if I go back into stat, calc, and these are all of the regression models that your calculator offers. Not all, you can keep cursing down, but if you keep going down, 0 is exponential regression. That's the one I want. So it comes back to the home screen. Again, we want to give it our X values, our Y values, and I'm going to tell it to put that function into Y2. I don't want to write over the linear function in case I want to come back to it for some reason later. Okay, press enter. And it gives me a new exponential function here. So I'm going to go ahead and jot that down. Okay, so there's my exponential model. Now, notice that it's got this 8.153 e to the negative 17. That tells us we've got scientific notation. We've got a really, really small number here. So we've got 17 shifts of the decimal place to the left. So nearly 0, and then we've got our x value. No, that should be our base. Let's try that again. got to have our variable in there somewhere. So we've got this as our coefficient. And then where the b is actually our 1.025. And that is raised to the x power. Okay, so that's what we're looking at there. That's our latest prediction model. Okay, notice the R value on that one is closer to 1. That's a little different value than our linear regression. A lot closer to 1, so that gives me a better feeling. Again, I want to see it on top of my graph, so if I go to y equals, or just go straight to the graph, I'm going to leave my linear on there just to see it. Okay, so now it's drawing my exponential. That looks way better. It's a lot closer to my points, especially at the first half of our data set. But notice towards the end here, it kind of falls short of these last 2 points. But man, for these first points, it looks really good. So I feel a lot better about this model, especially for the first 3/4 of the data. But let's do a residual nonetheless. So if we go back to our stat plot, I want to turn plot 1 off. If I go to plot 2, I want to turn that on. Your calculator automatically recalculates the residuals. And the residuals, if we go, let's go back to our original plot. Let's talk about residuals. We need to know what those residuals are. Okay, so the residual, what we mean when we say residual is the difference of a predicted piece of data from the actual piece of data. So if we're looking at this last point here, we've got an actual data point for 2010, which was 900,000 and some change. The difference between that point vertically and the same x coordinate put into our function, so whatever that y value is our residual for that x coordinate. So now let's go in, let's turn plot 1 off, let's turn plot 2 on. I want to go ahead and turn off these 2 models and then refit our data. So again, here's our residual plot. Actual x's are on the horizontal axis. Residuals are on the y, which is the difference of actual y and predicted y. Okay, and now there's still a pattern, but it looks a lot better than the linear model. I would still say, especially on this tail end here, that I would not feel comfortable making predictions outside of the range of actual values that we have. Okay, so any extrapolations outside of our data set, I wouldn't feel comfortable using this model. But if we're going to use it, for example, in number 3 to do 1978, which is within our data, I feel good about this model. Okay, so let's say great for interpolations. An interpolation is a prediction within our set of actual x's here. And maybe not so good for extrapolations. Because of this tail end here. All right, so finally, let's go back to our exponential model and back to our actual set of data. So turn on plot 1, turn on y2, refit your window. And let's use our model to predict what the population was in 1978. All right, to do that, on the graph screen, I can just hit trace. Notice that they immediately highlight plot 1. I don't want plot 1, I want y2, which is our predictor equation. So again, I'm going to hit 1978. That's our x value, press enter. And then the Y value is that prediction there. So the prediction for 1978 was 317,901.5 people. Kind of funny to say. So if we look at our actual data, 78 is real close to 80. So it's a little high, but it's close to the 1980 value. Okay, if we look at 2020, again, if we hit trace again, select Y2, punch in 2020, then it's going to give us this prediction here, which is 913,578 and some change. And I would predict realistically that it would be higher than that, seeing as how our model dips lower than our last two data points, if that trend in increase of growth of population was to continue. Okay, so to recap, when asked to find a prediction model, put data into L1 and L2, look at it, graph it, determine what type of equation would best fit your data, check your R value, check how it looks on your data, check your residual plot for goodness of fit, and then use that model to make the required predictions.